Okay, we are going into geometry. Geometry, this is algebra 1. Here we are, geometry right here. And geometry, we're doing L12 through L16. Now, obviously, it's a lot. I can't make it a 2-hour-long video here, so I'm going to do my best with you guys. L12 through L16. L12 is, actually, L13, I think, is the same as 14 and 15, so I'll do 13, definitely. And then, obviously, 16 is a new one. All right, so write the coordinates of the vertices at their translation 4 units up. So when you're just going 4 units up, you're just adding 4 to the y values. You don't change the x values. You're just going up. So I'm just going to keep all my x values the same. So -8, -7, -7 again, and then -8 again. That's an 8. Oh, boy, that's a terrible 8. Ugh, jeez. And then to the y values, just add 4, because you're only going up 4. So -1 plus 4 is 3. -1 plus 4 again is 3. 5 plus 4 is 9. And 5 plus 4 is 9 again. And boom, there you go. Your first one. Done. Smart score of 81 now. Wow, we just jumped a whole bunch of levels there. I don't know if you can see that. All right, here we go. It says, do 2 things to this. First, reflect across the line x equals 1, and then, so second thing, so number 1 is this, number 1. Then the second thing is rotate 180 degrees counterclockwise. So it doesn't really matter what you do with 180 degrees, you're just changing the variable, you're just changing the numbers around. So first let's do that number 1 thing. It says reflect across the line, what is it? X equals 1. So here's x equals 1. It's a vertical line right here. Let me draw it out for you. There's x equals 1. And to reflect, you're just kind of, counting them over there. So I usually like to do these with the coordinates, anytime you're reflecting and stuff like that. So my coordinates here, I got 6, -5. 6, -5 there. W, it says, 14, -7? 14, -7. All right, lovely. V, it says 12, -11. Lovely. And then y, it says 8, -13. 8, -13. All right, so we're first going to reflect across the x equals 1. So I'm just going to literally count it. 1, 2, 3, 4, 5. So I'm 5 units away. 1, 2, 3, 4, 5. There you see it. So I'm just going to go 5 units away the other way. 1, 2, 3, 4, 5. Boom. There it is. That's the x value. So now, maybe that was a little tedious for you guys. I'm not really sure. But there is another way you could do that rather than just kind of counting. Let's go down here to y. If you see the 8, 8 is really 7 units away from 1. So I'm just going to do 1 minus 7 because I'm going to the left. 1 minus 7 is -6. So I'm going to stay on this line here, but I'm just going to go all the way over to -6 and put a dot. And there you go. So that's a reflection right there, just like that. Same thing with V. V, look at the x value, it's 12. 12 is 11 units from 1. So I'm just going to do 1 minus 11 and get -10. So again, I'm going to keep that same thing on that line. V, here I am. I'm just going to go all the way over to -10. That way I don't really have to, spend time counting, all that kind of stuff. W, 14. Again, the x values, because I'm reflecting over x, so I only care about the x values. The y values stay the same. 14 is 13 units from 1, so I'll do 1 minus 13, because again, I'm going to the left. 1 minus 13 is -12. So I'm keeping that on the same line. -12. Cool. There you go. So there's your new shape. That's at the reflection of x equals 1. So this first guy right here, you're going to get some new variables. What do we got here? -4, -5. -4, -5. The second one, what do we got here? -6, -13. Cool. -10 right there, and -11. And -12, -7. Nice. All right, so that's not bad. To do the reflection of 180, all you do is you flip the coordinates, right? So a 180 degree reflection or rotation, all you do for each one of these things is, I'm sorry, not switch them. All you do is change the signs. So just change the signs of all of these numbers here. So that'd be positive, 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 and positive. Okay, and then that would be it. Then you would graph it. So I'll start with the first one. Positive 4, positive 5. I'll do it in green. Positive 4, positive 5 is right there. Do that second one. Positive 12, positive 7. I'm going to go back over here. Positive 12, up to positive 7. Kind of hard, my big finger. Positive 10, positive 11. Positive 10, positive 11. That's where is it? There it is. Got it. And just going counterclockwise here. Positive 6, positive 13. Positive 6, positive 13. Where's 6 again? I lost it. There it is. Cool. And again, I'll do in blue. Boom, 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 boom. And then you would hit submit from there. And just like that, you would get it right. All right, nice. So that's graphing the image. Reflection first, and then rotation. All right, next. Let's see what we got here. Go. All right, so I guess we jump back a level. Smart score of 72. I guess we went backwards a little bit, regress a little bit. That's okay. Graph the image at a rotation of 180 degrees clockwise. All right, so again, 180 degrees doesn't matter. It's just changing the signs. So here we get 2, negative 1. Here we get 7, negative 1. Here we get 2, negative 8. So you're just going to change all of those signs. Keep the numbers where they are, but change the signs. So negative 2, positive 1 will be right there. Negative 7, positive 1 will be right there. And, that's a gross dot. Jeez. And then negative 2, positive 8. Negative 2 up to 8. There it is. So there you go. 180 degrees, you're just changing the signs of the coordinates. And that was not bad. I like going backwards. Again, we went backwards. Smart score of 64 now. Oh boy, we're regressing. We're regressing a lot. All right, let's see what this one says. It says write the coordinates across the y-axis. Well, whenever you rotate or flip across the y-axis, the y values stay the same. So y values stay the same. Y-axis, y values are the same. The only thing that changes are the x values. It's just the sign. So the y values stay the same, so I'm just going to go ahead and do that. 3 and 3. And then the x values just change the sign. So positive 9, positive 4, positive 1, positive 6. Hit submit, and you're done. Oh no. Ugh. Go. Okay. Boom. Smart score for 7. So again, we're kind of regressing a little bit here. 90 degree counterclockwise. So the rule for 90 degrees is you flip the numbers, and then change the sign in the direction you're going. So I'll just write that rule down. So let's say I have a coordinate here, it's x comma y, and you do a 90 degree rotation. So you're going to change the numbers. So your y value goes to the front, your x value goes to the back. That's really sloppy, goodness gracious. And since I'm going counterclockwise, here it is, I changed the sign of the y value. So I'm going to leave that rule there for 90 degree rotations. Go ahead and find your coordinates first. So A is 6, 1, B is 7, 3, C is 6, 10, and D, what was that? Looks like a 5, 3. Yeah, sure, that looks good. 5, 3. All right, so now just take all of those coordinates and go through that rule right there. So 6, let's see. So 6, 10, here it is. That's the C. That's going to be 10, 6, but you're changing the sign of that number. So negative 10, 6. So there's that one right there. 7, 3. put that up there, 7 comma 3. Go through that rule. It means you're going to flip the numbers, so 3 comma 7, but then change the sign of that one right there. So there's that guy. What do we got here? 6 comma 1. Let me just get this out of here. In my way. Move. 6 comma 1. 6 comma 1. There it is. Go through that rule. That means flip the numbers, 1, 6, and then change the sign of that one right there. And then last but not least, 5 comma 3. Oops, different color. 5 comma 3. Okay, that rule says change the numbers. So flip to the spots. So 3 comma 5. And then you're going counterclockwise, so you change that number right there. Bam. And there you go. So those are your new coordinates for your kite. And then you just go ahead and plot those out. Negative 10 comma 6. Negative 10 comma 6 right there. Negative 3 comma 7. Negative 3 comma 7. Oh man, this is tough to see. There we go. Negative 1 comma 6. Negative 1 comma 6 is right there. And then negative 3 comma 5. Negative 3 comma 5. And then bam. That's what you would plot as your new kite. Yay. All right. What do we got here? L13. Okay. Dilate. L13 with the dilations. Here we go. Graph the image at your dilation of scale factor of 3. So you literally, and everything is going to be centered around the origin. Don't worry about if it's centered anywhere else. If it does, then I'm not going to give you that question. So you literally just take all the coordinates and multiply them by 3. That is it. So this is, the S1 is 2 comma 0, so it's just going to be 6 comma 0. So right there, there's S. Let me do a different color. There's S. S prime, I'll say. S prime. R is 2 comma negative 1. So again, just multiply those numbers by 3. So 6 comma negative 3. 6 comma negative 3. That would be R prime. Same thing with the T. So it's negative 3 comma 0. So multiply by 3. It's going to be negative 9 comma 0. Right there. T prime. And Q is negative 3 comma negative 1. So again, multiply both of those numbers by 3. So negative 9 comma negative 3. Negative 9 comma negative 3. There you go. There's Q. Q prime. And bam. There you go. That's a huge dilation right there. Boom. 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 That would be your answer. All right, moving along here. What do we got here? L13 and go. Let's move. There we go. Dilate by a scale factor of 1/4. That's the same thing as dividing by 4. So again, I would take all of these coordinates and just divide everything by 4. Literally just divide by 4. Or multiply by 1/4. So let's start with S. 4 comma 4. Divide those by 4, you get 1 comma 1. There it is. It's all a little tiny guy. R is 4 comma 0. Divide by 4, so you get 1 comma 0. Yay. T, negative 8 comma 4. So you get, divide by 4 again, you get negative 2 comma 1. Negative 2 comma 1. So one more time if you missed that one. T is negative 8 comma 4. Divide both of those numbers by 4, because that's your scale factor of 1/4. And that is how you would get that guy, negative 2 and 1. Q, negative 8, 0, so divide by 4, you get negative 2, 0. There you go. That's that. Alright, lovely. What do we got here? Still Z13. And we're still doing some dilations by a scale factor of 1/5. So that just means divide everything by 5. So as you can see here, all these points are 10, 10, 10, 10, 10. So it's just going to be divide by 5. So 2, 2, 2, 2. Okay. So 2 comma 2. 2 comma 2. Or negative 2, negative 2. Negative 2, negative 2, and 2, negative 2. Dividing all those by 5. That was an easy one. So score for 38. Scale factor of 5. Again, take your coordinates, multiply everything by 5. Scale factor, 5. It's nice, easy. So U is 2 comma 1. Or sorry, 1 comma 2. Just put the numbers around. Times it by 5, you get 5 comma 10. So 5 comma 10, and there it is. There's U right there. V, negative 2 comma 2, so negative times it by 5. Both numbers by 5, so negative 10 comma 10. It's way over there. Wow, jeez. Negative 2 comma negative 1, so times 5 is negative 10 comma negative 5. Whoa. Negative 1, so negative 5, negative 5. Wow. That's big. Ugh, man. Huge. There we go. L16. Okay, so 14 and 15 are very, very similar to 13. It's just dilations. Anything about the origin? Oh, sorry, I'm drinking my coffee. It's 7:50 a.m. Oh, I just got in from a drone flight. All right. Line L has the equation of 2x plus 1. Write the equation of the image after a dilation with a scale factor of 5 centered at the origin. So again, everything's going to be centered at the origin. I'm not going to worry about anything else, especially when we're doing it virtually. If we were in school, then yeah, I would do some other things, but I'm not going to here. Okay. Lovely. So anytime you dilate a line, that's what this whole section is about, dilating lines. So this line is dilated by a scale factor of 5. Anytime you dilate a line, the slope never changes. Slope never changes because the lines are parallel. That's what it says, parallel lines. So the only thing that changes is the y-intercept. So that's it, guys. Scale factor of 5, multiply the y-intercept by the scale factor, and you're done. So slope never changes, so it's just going to be y equals 2x. And then multiply the y-intercept by 5. So that number right there times that by 5. So 1 times 5 is 5. And that's your answer. That easy. Done. Scale factor of 5 again. So again, the slope never changes, so it's going to be 1/3 x. Then times that number by 5. So plus 5. That's your answer. Okay. Look at that. Smart score 55 already. So it's just a different representation here. Y equals 1/2. Sorry, get that thing out of the way. Y equals 1/2 x plus 8. So the slope never changes. So you take the scale factor and multiply it by 8. So 8 times 1/4, or you could say 8 divided by 4 is 2. So y-intercept of 2, and the slope of 1/2. So up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. And you just graph that line right there. And hit submit, and you'll be good to go. All right, lovely. Smart score of 81 already? Wow, smart score of 93. Yeah, you guys are lucky today. 11/4 x minus 2. So again, the slope never... oh, gosh, what did I just do? It's this one. No. There it is. Cool. Slope never changes. 11/4 x. So that's in there. That's done. Then just multiply the scale factor times the y-intercept. So scale factor is 4 times 2 is... negative 2. It'd be negative 8. So 11/4 x minus 8 would be your answer there. Hit submit, and you're done. Okay, L16. Smart score, did I go any higher? Oh, I went back. I went lower. All right, smart score of 81 now. If you can see that over there. Hello. Dilate by 3. So again, slope stays the same, so negative 1/2. And you take that number and you multiply the scale factor by the y-intercept, so negative 9 now. Negative 9. Slope stays the same, negative 1/2. So you're at negative 9, here I am, and you go down 1 over 2, down 1 over 2. If you run in a room like I did, you go up 1, left 2, so up 1, left 2, up 1, left 2. And you just plot that like that. Oh my gosh, that end of it got a little squibbly wobbly. Oh, boy, oh boy. What do we got next? What? Is that it? No, is it really? Awesome. All right, you guys are done. Have a great day, everybody.